Hello students, good afternoon to all of you. Good afternoon Agashri, good afternoon Pallavi. So am I audible and visible? I'll launch a poll. Just let me know the answer in the poll, okay? I have launched a poll. Just tell me whether I'm visible and audible to all of you or not. Okay, fine. So very good afternoon to all of you once again. So Nagashri, where were you for the last few classes? Yesterday I couldn't find your name, and Pallavi also. Yesterday I think you both did not join for the class. What happened? JNB, Ramnagar, Yanam, Kokrajhar. We join in the name of Jainish. Okay, okay, fine, fine, fine. Okay, okay. Got it, got it. Okay, okay, my dear students. So now let's go into the topic. So today I think mostly we will complete this electrochemistry lesson. Okay. So this is a physical chemistry lesson. That's why we are having more number of formulas, and we are about to solve more number of numericals. Okay. So I think today we may complete this. Okay. Let's hope for it. Now let me give a recall test for you. So here I have got two questions. The first question is, what is molar conductivity? Just you have to give me the formula for molar conductivity. Molar conductivity is denoted by the letter lambda m. We have discussed yesterday. So it is equal to what? Can anyone give me the formula in the chat box for molar conductivity? Very good. Kappa into, very good, very good. Kappa into 1000 by m. Correct. So, very good students. So la molar conductivity is kappa, which is actually conductivity into 1000 divided by molarity. Now the second question is, what is the relationship between conductance and conductivity? Conductance is denoted by the letter G and conductivity is denoted by the letter kappa. So what is the relationship? So what is a formula which relates conductance and conductivity? It is also very easy only. Any idea about the relationship between conductance and conductivity? Has anyone got the answer for this question? Yeah. Sigma A by L. We did not discuss about the term sigma, no? That is rho. Rho into rho we have discussed. We did not discuss anything like sigma, no, Nagashri. So actually the answer is kappa is equal to G into G star. Yeah. Jane Mikokrajar has got the correct answer. Kappa is equal to G into G star. Very good, my dear students. So this is the relationship between conductance and conductivity. So today we are going to cover the last topic of this lesson, which is batteries and corrosion. So yesterday itself I was about to complete this. I thought of completing this, but we couldn't do it because of the time. Now today let's continue this. We'll try to finish this, and we will try to solve some previous year's questions of this lesson from JEE and NEET. Okay. So the learning objectives in batteries and corrosion topic is introduction of batteries and primary batteries. So we will discuss about primary batteries and secondary batteries and fuel cell. And at last we will discuss about corrosion. Okay. So let me go for introduction of batteries and primary batteries first, and then we will go for the next. Okay. So coming to the topic, introduction to the world of batteries. Why do we need this battery? Or what is happening inside this? So what is the use of batteries? Why we need to use this battery? Any idea for anyone? Or what is happening inside the battery? What are batteries? What are batteries? That is a more appropriate question I can ask from this. So what are batteries? To do it to spontaneous work? Okay. What about others? It is a combination of cells. Okay. Okay. Let me ask you in this way. Okay. So which energy is getting converted to which type of energy? So dash energy is converted to dash energy. Can you fill the dashes? Electrochemical reaction happen in the battery. Okay. Very good, Sneha. Chemical energy into electrical energy. So Sneha has got the answer which I have expected actually. Others also have given me the correct answer. Oh, Priyanka, yeah, Kaushik, then we are students. Very good, very good. Most of you have got it. So here in batteries, chemical energy of the redox reaction is converted to electrical energy. Okay. So what is meant by a redox reaction? The reaction in which both reduction and oxidation taking place simultaneously is called as redox reaction. So here chemical is getting converted to electrical. Okay. So this is the basic definition of battery. So now batteries are classified into two. One is primary batteries and the other one is secondary battery. Okay. So here in the book, in our book, in the NCERT book, we are provided with some examples for primary batteries and secondary batteries. So the examples which are coming under primary battery is the dry cell and the mercury cell. So first one is the dry cell, second is the mercury cell. And coming to secondary battery, we have lead storage battery. Okay, so the one which you are seeing on the screen is called as lead storage battery. Now let's discuss each and everything. So let me start with the primary batteries first. Okay, so primary batteries. So what are primary batteries? So the reaction occurs only once, and after use of over a period of time, battery becomes dead and cannot be reused again. So those batteries which cannot be reused again are called as primary batteries. Okay. So the examples are the dry cell and the mercury cell, which I have already given you. Okay. So this is the dry cell and this is the mercury cell. Got it? So can you give some examples for objects in which we are using the primary battery? Can anyone give me the examples of the object or the things in which we are using these primary batteries? Watches. Very good. Torchlight, remotes and watch. Clock. Yeah. Yeah. Wall clock. Very good. Very good. Very good, students. So in those materials, we are using the primary batteries only. Okay. So now let's discuss the reactions and the setup of dry cell. Okay. So this is the battery dry cell. So here we have electrodes. One is a cathode and the other one is anode. So cathode is made up of a carbon rod, which you can see on the screen. And we have anode. Anode is made up of zinc. Okay, it is a zinc cup. And also we have some paste inside this. So this is the paste. Okay. So this is the paste. So it is manganese dioxide and carbon black and ammonium chloride paste. So that is present in between this cathode and anode. Got it? Now, what are the reactions that is going to occur in cathode and an anode? So first let me go for the reaction at cathode. Sorry, anode. Okay. So I already told you that oxidation occurs in anode. Okay. So anode is zinc. Zinc is going to get oxidized. So zinc is going to release two electrons and it is going to get converted to zinc 2 plus. So zinc from 0 state to 2 plus state. It is going from 0 state to 2 plus state, and it has got oxidized. Okay. Now what is going to happen at cathode? So in cathode, reduction occurs. In cathode, reduction occurs. So here the manganese dioxide reacts with ammonium ion by gaining one electron, and it is getting converted to manganese oxide hydroxide and ammonia. Okay, so here if you see to the oxidation state of manganese, it is plus 4. Okay, whereas here, so manganese is taken as X and we have 2 oxygen. So minus 4, and for hydrogen it is plus 1, which is equal to 0, and X is equal to plus 4 minus 1, which is plus 3. Okay, so the manganese is going from plus 4 to plus 3. So decrease in the positive charge. So it is called as reduction. Here increase in the positive charge and here decrease in the positive charge. So zinc is getting oxidized and manganese is getting reduced. Okay. So the zinc 2 plus ion which has formed at the anode, that will react with the NH3 which has been formed at the cathode. And these two species, they will form a compound, coordination compound. Okay. And the coordination compound is zinc tetraamine complex. Okay. Zinc tetraamine. Let me erase the thing. So zinc 2 plus reacts with NH3. Okay. So these two are the products that we obtain from anode and cathode. Those two species react with each other and they form a coordination compound. Okay. So these are the reactions of dry cell. Now the next is mercury cell. So any doubt from dry cell for anyone? Is everything clear in the dry cell part? Students say yes or no? Is it clear for all of you? So you need to study the reaction occurring at anode and the reaction occurring at cathode. That's all. Okay. Okay, great. Now let us move on to the mercury cell. Yes. Thank you so much for your response, my dear students. Now let me go for the second example, which is mercury cell. So this is the picture of mercury cell. And here also we have electrodes. One is cathode, the blue color part is the cathode and the red color part is the anode. Okay. And also we have some yellow color line which is separating between this cathode, which separates the cathode and anode. So that's why we call that as separator. Okay. And also we have a gasket around this, no? So this is the gasket and this is the cell can. The outer layer is called as cell can and the one which is present inside is called as gasket. And this part, okay, this part is called as anode cap. This is called as anode cap. So this red color part is the anode, right? So this is covering that anode, red color material anode. So that's why it is called as anode cap. Now what is the reaction that is going to occur at anode? So here zinc amalgam, zinc mercury is called as zinc amalgam. So that zinc amalgam will react with the hydroxide ion and it will be converted to zinc oxide. So here the oxidation state of zinc is 0 and here the oxidation state of zinc is plus 2. So it has lost 2 electrons and it has got oxidized. So oxidation is occurring at anode. Okay. Now in cathode, what is going to happen? In cathode, the mercury oxide, HgO, in which the mercury is in plus 2 oxidation state, is going to gain 2 electrons from the zinc. Okay, zinc has lost 2 electrons, right? So this mercury will gain those 2 electrons which has been given by zinc and it is going to get converted to mercury in the liquid state and hydroxide ion is produced as a byproduct. Okay, so the oxidation state of mercury here is 0. So here mercury is going from plus 2 to 0. So where it is called as, in which it is called as reduction. Okay, so zinc is getting oxidized and mercury is getting reduced in mercury cell. Clear for all? So this is all about the primary batteries. So study the definition for primary battery. The batteries which cannot be reused again are called as primary battery. There are two examples given to us. One is dry cell and the other one is mercury cell. So in both the cells, we have studied two reactions which is occurring at both the electrodes. You need to know which one is getting oxidized and which one is getting reduced in each cell. So that is all you are going to do. Okay. Shall I go for the next one? Secondary batteries. Any doubt from the primary battery part for anyone? No? Okay, great. So now let us go for the secondary batteries and fuel cell. So let us discuss secondary batteries first. So what do you think about the definition of secondary battery? Primary batteries means which cannot be reused. What are called as secondary batteries? Can anyone give me the definition for secondary batteries? Is it rechargeable? Is it rechargeable? Can we recharge the secondary battery? Can we reuse? Or it cannot be reused? We can recharge them, which is reusable. These can. Very good. So it can be recharged. It can be recharged. Okay, okay, Srujana. If time permits, I will discuss it for sure for you. Okay? Or else you can stay at the last so that I can explain that for you alone. Okay? Once I complete the class, just stay. I will explain. Yeah. Yeah. Sorry, students. Srujana was asking something. So I have just replied her. So the definition is it can be recharged by passing current through it in the opposite direction so that it can be used again. So what are the examples of secondary batteries? Examples are lead storage battery and nickel cadmium cell. So this is the picture of lead storage battery and this is the picture of nickel cadmium cell. Now let us discuss about the lead storage battery. So in the lead storage battery, we have the cathode. Okay, so positive sign is given now. So that light pink color thing is called as the cathode, and the negatively charged, the blue color part, that is called as anode. And also we have negative plates. Okay, so negative plates are made up of the lead grids filled with spongy lead. So basically that blue color thing, which are actually the negative plates, they are made up of lead. Okay, they are made up of lead. And the positive plates, the positive plate means the cathode. Okay, so they are made up of lead grids filled with lead dioxide. Lead dioxide. And also we have 38% sulfuric acid solution inside this. It is an acidic solution. And this is the setup. This is the anode, cathode, negative plates part and positive plates part of lead storage battery. Now, what are the reactions that is going to happen in lead storage battery? So the reactions in lead storage battery are, first we'll discuss about the anode reaction. At anode, the lead will react with the sulfate ion present in the sulfuric acid. So we had 38% sulfuric acid, right? So in that we have sulfate ion. We have H2SO4. So this is sulfuric acid. So this can be dissociated to 2H plus and SO4 2 minus. Okay, this is the sulfate ion. So the lead is reacting with the sulfate ion and it is getting converted to lead sulfate by the release of 2 electrons. So who is giving these 2 electrons? The lead is giving out these 2 electrons. So lead is getting oxidized. So here the oxidation state of elemental lead is 0 and here since sulfate has 2 minus charge, lead is 2 plus. So lead is going from 0 to 2 plus, so it is oxidation. Okay, oxidation happens by the loss of 2 electrons for lead. Now at cathode, what is happening? The lead dioxide which we have in the positive plate. So that will react with the sulfate ion present in sulfuric acid solution. Okay, and it gains 2 electrons. It gains 2 electrons because in cathode reduction occurs. So gain of electron takes place and that will be converted to lead sulfate. It will be converted to lead sulfate. So here the oxidation state of lead is +4 because we have 2 oxygen, right? For 1 oxygen it is -2, and if it is 2 oxygen it is -4. So the oxidation state of lead is +4. And here the oxidation state of lead is +2. So +4 to +2. So it has gained 2 electrons and it has got reduced. In both the cases, lead is getting oxidized and lead is getting reduced. Because in both the positive plate and negative plate, we have lead only. It is made up of lead only. Okay. So these are the reactions occurring at 2 electrodes. Now, on charging the battery, what happens? The reaction is reversed. Okay, the lead sulfate on cathode and anode is converted to lead and lead dioxide again, respectively. Okay, so in both the cases, we are getting lead sulfate, right? So during the charging process, what will happen? This lead sulfate will again go to lead dioxide form, and here the lead sulfate will go to the lead back again. So again we use that and we'll charge. During the charging, this will be converted to lead and lead dioxide again. So we'll be using the thing and again we will charge. This reaction occurs continuously. Okay, clear? This is about the lead storage battery. The next one is fuel cells. Any doubt from the anode and cathode reactions of lead storage battery for anyone? Is it clear? Okay. So now coming to the fuel cells. The third is the fuel cells. So we have discussed about primary battery, we have discussed about secondary battery. Now we are going to discuss about the primary cells. Sorry, fuel cells. Okay, fuel cells. So the galvanic cells that are designed to convert energy of combustion of fuels. Cells that are designed to convert the energy of combustion of fuels. Okay, combustion means heating something in presence of oxygen. That is called as combustion. Okay, now we are going to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into the electrical energy. So what we are basically doing here, we are converting the chemical system to electrical. Chemical energy to electrical energy. Okay. So if we are converting the energy of combustion of fuels into the electrical energy, then we call it as fuel cells. Fuel cells. So I'll show you the picture. So this is the picture of fuel cell. I can say here we have 2 electrodes. One is cathode and the other one is anode. While discussing the anode cathode reactions, I will explain you this picture in detail. Okay. So now at cathode, what is going to happen? Oxygen will react with water and they'll gain 4 electrons and it will be converted to hydroxide ion. OH minus is called as hydroxide ion. Okay. So here gain of electron takes place. Gain of electron takes place. So these are the oxygen molecules. So these oxygen molecules, they are reacting with this water. These oxygen molecules, they are reacting with the water and they gain the electron. They gain the electrons. So here see, here you all see electrons. This is one electron and this is the other electron and this is the cathode and they are all gaining the electrons. So by gaining the electron, it is getting converted to OH minus. Okay. Now at anode, what is going to happen? At anode, the hydrogen will take the hydroxide ion which is being produced from cathode. Okay. So H2 takes OH minus and it is getting converted to H2O. H2, so these are the hydrogen molecules. So H2 is reacting with OH minus and they are losing the 4 electrons. So 4 electrons are getting lost. So you can see the arrow, no? They are getting lost from the hydrogen and oxidation occurs for hydrogen. Okay. So here you can see the oxidation state. Oxidation state of oxygen here is 0. and here it is -2, and here the oxidation state of oxygen is, so it is X, and this is +1, it is 2, right? And here it is 0, and here it is -2. So what is happening here? 0 to -2, 0 to -2, and the loss of electron takes place. Here gain of electron takes place. Gain of electron means reduction, loss of electron means oxidation. Okay. So what is the overall reaction for this fuel cell? So how to get the overall reaction, students? Cancel out the common terms and write the remaining species. Okay. So the overall reaction will be, so 4 electron will get cancelled with each other. 4 OH minus will go away. And here I have 2 water molecule, and here I have 4 water molecule. So just let me erase. Okay. 4 electron, 4 OH minus, and here 2 water molecule. And from 4 water molecule, you can remove 2. So the remaining 2 will be there. Okay, so what are the things we have on the left hand side? We have O2, we have 2H2, which is equal to, which is giving 2H2O. This is the overall reaction for the fuels. Okay, hydrogen reacts with oxygen to form water. Okay, clear? So here hydrogen is reacting with oxygen. So energy of combustion of fuels like hydrogen is getting converted to electrical energy in the fuels. Okay. Shall we go for the corrosion topic? Is everything clear till this from primary, secondary and fuel cell topic? Shall I go for the very last topic of this lesson, which is corrosion? Yes. Okay. So I'll give you the definition of corrosion first. So before I give the definition, can anyone tell me what is corrosion? Have you heard of this term corrosion? You can give me the definition of corrosion, or you can tell me whether oxidation occurs in corrosion or reduction occurs in corrosion. Either give me the definition of corrosion or tell me whether oxidation occurs in corrosion or reduction occurs in corrosion. What do you guys think of this? So here you all can able to see a metal picture. Okay, so metal is shown to you. Yeah, very good. Ratna Kumari, Kaushik and Kokraja students, many are saying that oxidation occurs. Very good. So in corrosion, a metal, a metal is oxidized by the loss of electrons to oxygen, and formation of oxides happens here. Okay, oxides happen. Now, this corrosion, what does it do? It slowly coats the surface of the metallic objects, okay, with oxides. So, the oxide layer will be formed around the metal, okay, or other salts of the metal. So, because of this, what will happen, you know? So, here I'll show you the picture of an object. So, what is happening, you see? The silvery white color of a metal is of an object is metallic object is turning into brownish color. So what does this mean? Oxidation has happened. So why do we observe the color change here? Because of the presence of oxide layer. Okay, here in this second half. So an oxide is forming a layer. Oxygen is forming a layer on the surface of the metal, and that's why the change of color is happening. Okay, this is what we call as rusting in some cases. Okay, so oxidation of a metal leads to the rusting and many other things, and the object gets destroyed. We cannot use it again. So this is actually called as corrosion. Now, what is corrosion of iron in the atmosphere? So if I take an iron block or some object which is made up of iron, what is going to happen to that iron metal when it is present in the atmosphere. So this is what happens. So we have the iron block. This is the iron block. Okay, this is the iron block. And the iron is getting converted to iron oxide. Iron is getting converted to iron oxide. So first of all, what this iron will do? Iron will lose two of its electrons and it will be converted to iron 2 plus. It will be converted to iron 2 plus. So like this, all the ions, they will lose the 2 electron and it will be converted to iron 2 plus. And that iron 2 plus will react with the oxygen which is present in the atmosphere. Okay, so in the atmosphere we have many gases. No, one among the gases is oxygen. So it will react with oxygen in the atmosphere and it will be converted to Fe2O3. It will be converted to Fe2O3. So the two electrons which is coming out from each ion, so they will come together and all the four electrons will be taken up by some other species. Some other means it is H plus and O2. H plus and O2. And they will form H plus and O2 react with each other and they will form a water. Okay. So basically what is happening here? Oxidation of iron. Oxidation of iron is happening by the loss of two electrons and we call this oxidation as atmospheric oxidation. It is atmospheric oxidation. So Fe2 plus, which is formed by the loss of two electrons, will react with the water. It will react with the water present in the atmosphere. Water means the moisture. Okay, so in the moisture we have H2O molecules, right? So it will react with the water, the moisturous part which is there in the atmosphere, and also it will take half a molecule of oxygen and it will be converted to Fe2O3. Okay, so in Fe2O3, what is the oxidation state of iron? Can anyone give me the oxidation state of iron in Fe2O3? Is it +2 or +3? Very good. Very good. It is +3. So here it is moving from +2 to +3. And we call this oxidation as atmospheric oxidation. Okay. And also oxygen will get reduced. Okay. So here oxygen is moving from 0 to -2 in water. So it is getting reduced here. Reduction of oxygen also takes place. And that oxygen reaction is given here. Okay, so gain of electron takes place. This is actually called as reduction and here loss of electron. So it is called as oxidation. So now this is all about the corrosion of iron in the atmosphere. How to prevent this? We cannot stop the gases which is present in the atmosphere. No, we are provided with many gases in the atmosphere. We cannot say or we cannot tell the oxygen not to react with iron objects which we are having in the building, in the day-to-day life which we are using. So what to do? What are the preventive measures for this corrosion? Any idea? What are the preventive measures for this corrosion? Galvanization, painting, zinc coating, painting. Okay. Okay. The simplest method to avoid corrosion is to prevent the surface of the metallic object to come in contact with atmosphere. So how to prevent that thing? How to prevent? What are the preventive measures? So I am going to give you three measures. Okay. The first thing is by covering the surface with paint or some chemicals. Chemical name is important. Okay. So here the chemical is bisphenol given in your book. So you can use bisphenol or you can paint the metal. Okay. So that the oxidation can be stopped. The second method is by covering the surface by other metals like tin, zinc, etc. So if I have iron, so this iron metal can be coated with or not coating, it can be covered by the other metal. like zinc or tin. Okay, because why we are using zinc and tin? They are inert. Inert means they will not react with anyone. They will not react with oxygen, they will not react with nitrogen, they will not react with any other elements present in the atmosphere. Okay, so that is called as inertness. So if they do not react with the oxygen, they are not going to form the oxide layer, right? So, so that our object can be saved. Our object can be the iron object, the iron rod or the iron or the materials which is made up of iron can be saved from the oxidation. Clear? So that we can prevent the rusting and the other things. So this is the second method. First thing is you can use the paint or you can use some chemicals to paint it, or else you can cover one metal by the other metal, and that other metal should be inert in nature. They should not react with any other elements. So that type of nature it should have. Now the third method is by providing a sacrificial electrode of another metal like magnesium and zinc, which corrodes itself, but it will save the object. If the object is made up of iron, let me take iron as an example. Okay, if the object is made up of iron, and if you are using some electrodes like magnesium and zinc, so what they will do? So magnesium will get corroded with each other. Okay, all the magnesium part will get corroded, but it will save the object which is present inside. Okay, so iron can be prevented from the oxidation, but magnesium will get corroded with each other. Okay, so these are the preventive measures for corrosion. You can use either one of these three methods. Got it? So these are the things. Now coming to the summary of batteries and corrosion. With the help of battery, chemical energy of the redox reaction is converted to electrical energy. And there are two types. One is primary battery, which cannot be reused, and the secondary batteries can be reused after charging. In corrosion, metal is getting oxidized by the loss of electrons to oxygen and formation of oxides. Okay, so these are the things we have discussed in this particular batteries and corrosion topic. So with this, the lesson is getting over. Okay, now you need to, JNB Kadapa is asking me the previous slide. Are you done with this? JNB Kadapa? So who is watching behind JNB Kadapa ID? What is your name, my dear? Okay, fine. Fine. So now I have taken some previous year's questions from this lesson. So let's try to do some 3 to 4 questions, okay, in this 10 minutes or 15 minutes which we have. So here is the first question for you all. The E naught values for 4 couples are given: aluminium plus aluminium, thallium plus thallium, aluminium 3 plus aluminium, thallium 3 plus. This is thallium, okay, TL. Thallium 3 plus to thallium couple. E naught values are given. Identify the incorrect statement. Identify the incorrect statement. I'll give you some time, some 15 to 30 seconds to solve this question. Can you guys give me the correct answer in the chat box? You need to have the knowledge of your class 11 redox reactions lesson to solve this question. Okay. Just by looking into the E naught values, you can also find the answer by looking at the E naught values, but also you can use the redox reaction concept. Option B. What about others? Everybody is going for option D. Why option B is the correct answer? Can anyone explain? Why option B is the correct answer, my dear students? What is the reason? Thallium 3 plus is a good oxidizing agent. Thallium 3 plus is a good oxidizing agent. It is not a reducing agent. You know why? Thallium exists. Thallium is stable in its plus 1 state only. Thallium is stable only in its plus 1 state. So if it has to exist in plus 1 state, it has to act as a good oxidizing agent. Thallium 3 plus should act as a good oxidizing. What is meant by oxidizing agent? The species which gains the electron is called as an oxidizing agent. So if thallium 3 plus gains 2 electrons, it will be converted to thallium plus. Okay, which is actually a stable species. Got it? So thallium 3 plus here, since it gains the electron, it is an oxidizing agent and it is not a reducing agent. And also you see to the values of this couple, it is positive value, right? Positive means it should be an oxidizing agent. More positive. More positive means it denotes the oxidizing nature of that species. So option B is the incorrect statement. Option B is the incorrect statement. Clear? Aluminium is stable in plus 3 only. Aluminium is stable in plus 3. Yeah, aluminium plus 1 is unstable, so it is correct. Thallium can be easily oxidized to thallium plus and thallium 3 plus, but in both these form, one among these forms, both can form, but only one is stable. Okay, but thallium can be oxidized to both the forms. So that's why option D is also correct. And aluminium is more electropositive than thallium. It is also correct. Boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. So these are the group 13 elements, right? So here we are provided with aluminium and thallium information. On moving down the group, what happens? Electronegativity decreases, or I can say electropositivity increases. Okay. So aluminium is more electropositive in the sense in from which point they are saying, aluminium can exist in 3 plus, but thallium can exist only in 1 plus. So here the positive charge is more compared to thallium. So that's why aluminium 3 plus is more electropositive than thallium. So that's why option A is also correct. Option B is incorrect because of this oxidizing reducing term. Okay, is it clear for all of you? Shall I move on to the next question? Shall I move on to the next question? Okay. So this question I have discussed in yesterday's class also. Do you guys remember? So what is this? So this is a question from cold rush law, right? So here we have four compounds in which CH3COOH reacts with NaCl to form CH3CONA and HCl. So this is the reaction. And among these four compounds, the values of molar conductance of three compounds are given. We are asked to find out for one. So who is that one? For acetic acid, we need to find out. For NaCl, for sodium acetate, for HCl, we are given with those things. So just equate and get the value. I think we have got option C as the correct answer yesterday, right? Yeah. So just check whether you're getting 390.71. Yesterday we have discussed the same question from Cole Rashla. Now let me move on to the next question. Okay. So this is a question. Molar conductance of an electrolyte increases with dilution according to the equation. So why is this equation? is of the format of y is equal to mx plus c. Yesterday we have discussed, no? Y is equal to mx plus c. Okay. So root c is the will take the x-axis and lambda m takes the y-axis. Lambda m naught is the intercept, and this minus a is the slope m. Okay. So this is a straight line equation. Slope is negative, so I'll get a line like this. So if this is the graph, line will go like this. Straight line with negative slope. This is the equation given to us. Which of the following statements are true? So we have got 4 statements. Now we have to check which among these are true. Well, we'll go one by one. This equation applies to both strong and weak electrolytes. What do you guys think of this? Is it applicable to both? Is it applicable to both? Or only for one? Yesterday I have given you one graph which has got a straight line and also which has got a curve. I told you that straight line is for strong electrolyte and the curve is for weak electrolyte. So this equation, which is the equation of a straight line, is applicable only for strong electrolyte. Very good. It is not for weak electrolyte. So the statement A is wrong. It is applicable only for strong, not for weak. So A is wrong. So A is given in 2 options, no? So option A and option B are incorrect. So now let's go for the second statement. Value of constant A depends upon the nature of the solvent. Yeah. If the solvent is changing, the slope value will also change. If the solvent is changing, the conductance will also change. So B is correct. B is correct. So B is given in both the options C and D. So I have to go for the next statement C to find out the correct answer. So statement C says value of constant A is same for both BaCl2 and MgSO4. What do you guys think of this? Is it same? How to find out the value of A first? I'll tell you. First, let me take BaCl2. Okay. BaCl2 can be dissociated into Ba2 plus and 2Cl minus. So we have one cation and 2 anion. So how many ions are produced? 3 ions are produced for BaCl2. And for magnesium sulfate, the ions produced are Mg2 plus and SO4 2 minus. Okay. So one cation and one anion. So the total number of ions produced for MgSO4 is 2. Now you check. The number of ions are not same. In the first case, I'm getting 3 ions and in the second case, I'm getting 2 ions. So the value of constant A should also be different. It will not be same. Okay, but it is given that value of A is same for both. So C is also incorrect. Now let's go for D. Value of constant A is same for both BaCl2 and MgOH twice. So how to dissociate this MgOH twice? It will be dissociated into Mg2 plus and 2OH minus, right? So we have one cation and 2 anion. So there are 3 ions produced from this reaction. So for BaCl2 also we are getting 3 ions and for MgOH twice also we are getting 3 ions. So the number of ions produced is same. So the value of constant A is also same. Okay. So statement D is correct. So among the 4 statements, statement B and D are correct. So option D is the correct answer for this question. Is it clear for all of you? Do any of you have any doubt from this? Shall I go for the next question? Let us do one question from JEE and then we'll wind up the class. Okay. So I'll take this question as the last question for today's session. So the question says the resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 to the power minus 3 ohm centimeter. Okay, ohm centimeter. So what is given to us? Resistivity is given to us. So what is resistivity? Rho. Rho is given. And also the concentration of the substance is given. Concentration is 0.8 molar. And its molar conductivity is dash into 10 to the power 4 per ohm centimeter square per mole. So we are asked to find out the molar conductivity. What is molar conductivity? Lambda m. So we have to find out lambda m. So what is the formula to find out the lambda m? In the recall test also we have seen no lambda m is equal to kappa into 1000 divided by m. M is nothing but the concentration in terms of molarity. Okay. But we don't have kappa. We don't have conductivity. Instead of conductivity, we have resistivity in the question. So now what is the relationship between conductivity and resistivity? They're inversely proportional to each other, right? So kappa is equal to 1 by rho. So in place of kappa, let me write 1 by rho into 1000 divided by the concentration m. Alright. So now I have the resistivity value in the question. So let me substitute lambda m is equal to 1 by 5 into 10 to the power minus 3 into 1000 divided by the concentration is 0.8. Okay. Now you have to solve this entire thing. Are you getting 25, Kaushik? Very good. So this is 1000. So which is nothing but 10 power 3. Okay, so I can take this 10 power minus 3 to the numerator. It will be 10 to the power 6. Now I have to get the answer in terms of 10 to the power 4. So accordingly, do the rearrangement, multiplications and divisions and get the answer. The answer will be 25 into 10 to the power 4 per ohm centimeter square per mole. Okay. So value that we have to find is 25. Very good. Bhagat and Kaushik has got the answer. Okay, so this is a JEE mains question from 2023 January. Okay, 31st. So I hope this session is very useful and it is clear to all of you. And I think the entire electrochemistry is clear to you guys. Please revise once again. Go through the formulas. Write all the formulas in a formula notebook, which I have already told you. I hope you guys have written all the solutions lessons formula. Am I right? And I hope you guys have done it. And include all the electrochemistry formulas also in that same notebook and study the formula, keep revising, solve more number of questions from this lesson. So today we can able to do only 3 questions, right? So in the next session, I'll try to do some more questions from electrochemistry if time permits. Then I can move on to the next lesson, new lesson. Is it okay for all of you? Is it okay? Yeah. So now I'll launch a poll. Just answer for those things and then leave the class. Okay. Thank you so much, all of you, for attending the today's session. Okay. So meet you all with a new lesson in the next session. And if possible, I'll try to solve some questions from electrochemistry also. Okay. Thank you so much, students. Just wait for a while.